Hello, everybody. Welcome to this new lesson. So, this one is 7.4. We're going to talk all about this scientific notation stuff that you've been introduced to briefly. So, with scientific notation, we're looking at rewriting numbers that are either really, really big or really, really small. Now, this is useful in a lot of different fields. One field that's pretty cool that people enjoy a lot is astronomy. So anytime you're talking about planets and the distances between them, you're talking about huge, huge numbers. So you end up writing them in this scientific notation that we're going to talk about. So that allows us to express numbers that are either huge or tiny. When we get to the far end of this section, we're going to look into products and quotients of numbers. So multiplying and dividing with all of these things. So here's a couple steps for standard form to scientific notation. So that means the number is written as it is in standard form, either a really big number or a small number. We want to now write it in scientific notation, which means we have one digit number and then a decimal and then the rest of the number. And we'll write times 10 to some power. So step 1 tells us move the decimal point until it is to the right of the first non-zero digit. The result is a real number. So that could be 1, 2, 4, 7, whatever it is. Step 2, note the number of places in the direction that you move the decimal point. So for every place you move the decimal point, that's a power of 10. It's either going to be a positive or a negative power depending on the direction. So here's the rule. If your decimal point is moved to the left, you write the number as a positive power of 10, 10 to however many times you move the decimal. If the decimal is moved to the right, we write it as a negative power of n. The number is, again, the number of places you moved to the right. And then the last step, you can remove all unnecessary zeros. So here's what that's going to look like. So 1a, we have this huge number. And we want to write it in scientific notation. So that means we need to rewrite this as some number times the power of 10. We want one non-zero digit to the left of the decimal. Our decimal is currently way back here, so we're going to have to move it until we get to a non-zero digit, and we only have one non-zero digit to the left of our decimal. So if we were going to do that, that would take us all the way to here. Then we have 4.062, and we can think about how many times we move the decimal. So first step is to move that decimal all the way around. So you can move it all the way down so you get to 4.062. So this is now the number that we have that we're interested in. Now you have to think about how many places did you just move the decimal. So if you do some counting, you can see that it is 12 places that we moved the decimal. Now the direction here matters. So we moved it 12 places to the left. And this term left is important. So when we move it to the left, we're making our number smaller. So to balance that out, when we multiply by a power of 10, it needs to be to a positive value. So in the power of our 10 that we're going to write next to this is positive. So that's how we got this. So we know right away that we're dealing with 4.062 as a number, just because we moved the decimal until there's only one number to the left of it, so it looks like that. But when we go to write times 10 to what power to make sure that this expression means the same thing as what we started with, we have to think, is the power here a positive 12 or a negative 12? Well, we have a number here that's much, much smaller than what we started with. So in order to make it big again, it would have to be a positive 12. If that doesn't make sense, then you must remember, if you move the decimal to the left, your power is positive. So 4.062 times 10 to the 12th. Now all these zeros here are not necessary. We don't have to put those here because it's just extra zeros that don't help anything. We know it's 4.062. These zeros don't add to our number at all. We don't need those to be there. So when we go to write it, you can leave all those out. 4.062 times 10 to the 12th power. That is perfect scientific notation. So this is a much more concise, much more precise, much more efficient way of saying this huge number here. So that's our answer for scientific notation for 1a, 4.062 times 10 to the 12th. This number means the same thing as the huge number that we started with. Great, so with 1a behind us, we can now look at 1b. Notice this time we have a really small number, and we want to write it in scientific notation. So you can start to think about how that will change the power. So first, move your decimal until you only have one non-zero digit to the left of it. So our decimal is way back here, so we're going to have to move it to the right until we get to one non-zero digit to the left of it. That would be 8.23. And then we'll count how many places we moved it. 3, 4, 5, 6, 7, it looks like. So we move our decimal 7 places. Now the question becomes, which way should our power be? Should it be times 10 to the 7th or times 10 to the negative 7th? Well, if we move our decimal to the right, the rule tells us our power for our 10 should be negative. Another way to think about it is that we just took our original number and we cheated by making it bigger, making a small number much bigger. 8.23 is way bigger than this. So to balance it out, we have to multiply by a negative power to make it smaller again. So our power is negative. Looks like this. Now all these zeros back here don't add to our number, right? It's still 8.23. These zeros don't tell us anything else, so we can eliminate those. We don't need those there. And our perfectly done scientific notation, 8.23 times 10 to the negative 7 power for 1b. Always eliminate the extra zeros because those don't add to our problem. Okay, so we're moving backwards now. So given a number that's already in scientific notation, we can go back and write it in standard form. So that's going to use the following steps. So given a scientific notation problem, think about whether your power is positive or negative, the number up here. If it is positive, move the decimal that number of places to the right. If it is negative, we'll move it that number of places to the left. Step 3 tells us to insert any zeros, decimal point, and commas as needed. So 2a. We're given this scientific notation number, 6.49 times 10 to the 5th. They ask us to write it in standard form. So we need to write out the big number here that we're given in full form without all the times 10 to a power. So we're going to get rid of scientific, write it in standard. Write it how you would normally. So how do we do it? Well, times 10 to the 5th says we're moving the decimal 5 places. So the question now is which way? And you should know, since this is a positive power, multiplying by the same thing as 100,000, right? Times 10 to the 5th. 10 times 10 times 10. We're moving it 5 times to the right. We're making it much bigger. So the exponent is 5, so we're moving 5 places. And those should be 5 places to the right. So 6.49 times 10 to the 5th is the same thing as 1, 2, 3, 4, 5. We have this big number here now. 649,000 is the same thing as what we were given initially. So if you rewrite it, you want to insert the commas. The way you insert commas, you start at the back, count 3 units, put a comma. You can count 3 more, you put the next one. Since this one only has 6 digits, we stop there. So 649,000. And that's it, given all those steps. So we can work either way. Given scientific, we can write standard form, how you would normally. Or given a normal big number or a small number, we can put it in scientific notation. So either or, what we should be able to do as we work through these problems. Good. Now here's 2b. So we again want to write this number in standard form. So use the power, move the decimal, and write the number as it would be. So 1.8 times 10 to the negative 3. So the 3 up here tells me we're moving it 3 decimal places. Now the question is which way? So here's the kicker. If you have a negative power of 10, when you multiply it makes your number smaller. So which direction makes your number smaller in terms of when you move the decimal? Well, when you move it to the left, that makes it smaller. So we need to move it left 3 units. So our decimal's here. Move it left 3 units and then get our new number. So we talked about the exponent. It's negative, so we move the decimal back or left 3 places. 1, 2, 3 looks like this. So our decimal should be here now. If we write that, we get 0.0018. And that would be our decimal as best as you could express it. That's the same thing as what we started with, but now it is in standard form. There's no power left, and our number's written out nice and neat. So negative exponent, move your decimal to the left for 2b. Great, so if you can understand that, try this one. We want to write this number given that's already in scientific in standard form. So here's what we're given. We want to write it in standard form. So we see 10 to the negative 2 power. So we're going to move it 2 places. The question now is which way, left or right? Well, since it's a negative power, that makes our number smaller. So to make it smaller, we need to move it 2 units to the left. So here's our 3.16. We need to move this decimal 2 places to the left, right here. So here there would be a 0, and we could put a 0 in front of our decimal. So now if this decimal that we started with is now gone, this one's now gone, we now have 0.0316. So let's rewrite that. 0.0316. And that's it in standard notation. So which one is that? Well, clearly 316 is bigger. That's not right. 3.16 is too big. 0.00316 is too small. So it should be A if all those steps are right. For 2C, that's the same number. These match up. So 2C should be letter choice A, 0.0316. Awesome. So if we can understand all of that, now we can do problems that are more interesting, a little bit more work. We can multiply and divide with scientific notation. So here's how these are going to work. When you're given 2 binomials and you need to multiply with scientific notation, the way you can make it easy on yourself is to group the things that are the same. So we can group our whole digits, our numbers, 5 and 2.3. We can group those together and multiply them. Then we can also group together our powers, our 10 to something terms. So the 10 to negative 6 and the 10 to the 12th, we can group those and multiply those together. So notice the instructions also ask us to evaluate in scientific and standard form. So we need to make sure we write both. Okay, so here's what we're given. Now we're going to group the things that are alike. So group the numbers that we were given to start, 5 and 2.3. And then group the powers together as well. The 10 to the powers can be simplified. So we group them so that we can multiply things easier using the commutative and associative properties. So 5 times 2.3 is going to be a number. We can use the calculator to find that. And 10 to the negative 6 and 10 to the 12 we can find by looking at the powers and multiplying. So if you remember with our powers, what happens when we multiply our powers? Do we add them together or do we subtract? Well, as you're thinking about that, you should remember from all the work we finished that when we multiply powers, they should add together. So we're going to add negative 6 power and the 12th power together and get our next step. So that looks like this. Now notice on the left, 5 times 2.3 was 11.5. You can use a calculator to find that. And 10 to the negative 6 times 10 to the 12th, like we said, same bases. We add the powers when we multiply. So that's just 10 to the positive 6 now. So now we're looking at this as the next step. Now notice a couple things with the instructions. We have to write 2 answers here, both in scientific and standard form. So this would be close to scientific notation, but not quite. And the reason is because there's 2 digits to the left of our decimal. So we need to rewrite this so there's only 1. In other words, we need to move our decimal back 1 unit. So if we were to move our decimal to the left 1, we would need to multiply by 10 to a power. So multiply by 10 to the first power because we moved our decimal to the left. That was a rule from the beginning. In other words, looks like that. 1.15 times 10 to the first, that's what we said. And we still had 10 to the sixth already. Now to simplify, we have 10 times 10 to the sixth. Same basis, our powers add, so that should be 10 to the seventh. So now this is our scientific notation. 1 digit to the left and a power. That's great. Now they also ask us to express it in standard form, so go ahead and multiply it out and get that big number. You can do this in a calculator, or you can just move the decimal by hand. So 10 to the power of 7 means move it 7 to the right, making it really, really big. So that means 11,500,000. So these both are the answers we need, the scientific and the standard. So our answer is always twofold for these problems based on the instructions. 1.15 times 10 to the seventh and 11.5 million. Both of those are needed, and we'll see that as we work through similar problems going forward. Cool, so here's example 4. Notice it's a 4a problem. This time we have division, not multiplication. But it's very, very similar. We start by grouping the things that are alike. So we'll group together our numbers, our decimals in the beginning. And then we'll also group together our powers of 10 and simplify both. And then bring them back together. So first, group the things that are alike. Now 4.5 over 1.5, you could use a calculator to find that. Or you might notice that's almost the same as 45 over 15, which would be 3. So 4.5 over 1.5 is just 3. Now, as we go to simplify our powers here, they have the same base. And they have 2 powers here. We're dividing. So what happens to our powers? Well, the rule we learned last time, when we divide our powers with the same base, they subtract. So we should do 10 minus 8, which would be a negative 2. So everything I just said would give us that. Here we got a 3. Here we got 10 to the power of negative 2. Now the question is this in scientific notation? Well, yes. We have 1 digit to the left with the decimal. It's invisible. It's right there next to the 3. Times 10 to a power, so that's good. And they also ask us here to write it in standard form. So that means go ahead and multiply out your number. So 10 to the negative 2 means move it 2 units, our decimal. But since it's negative, we move it left. So moving this way 2 spots, we should get 0.03. We moved it once, we get 0.3. If we moved it twice, we get 0.03. So there's standard, there is our scientific, and those are both what we needed for this problem. So if you start by grouping, simplify, and then multiply it out, and that gives you both answers that you need. 3 times 10 to the negative 2. And then, of course, that as a decimal is 0.03. So that's it for 4a. Great, so if we can understand that, let's try 4b. Still division, a couple steps to simplify. So first, I'm going to start by grouping the things that I know are easily comparable that we can multiply. So I'm going to group together my numbers. 6.4 and 1.6. Awesome. Now I'm going to group together my powers. So 10 to the 4th and 10 to the 7th. Now, of course, all this is these two things are being multiplied with each other. So we know that's happening. I'll put that there just to remind us. Okay. So now we can simplify what we can here. So 6.4 over 1.6 actually comes out to be 4. So this is a 4 for those decimals. So we're going to get 4 times 10 to the 4th divided by 10 to the 7th. We have the same bases, and our exponents, since we're doing division, should subtract. So it's the same thing as 10 to the 4 minus 7, which is 10 to the power of negative 3. Just one step of subtraction, and we worked on those previously. So we have 4 times 10 to the negative 3 power. They also ask us to write it in standard form. So we're halfway done. Write this as a number multiplied out though. So power of 3, 3 units, but which way do we move the decimal? Well, negative makes it smaller, so we need to move it left. So if we moved it left, if we look at the number 4, we start here. If we move it left once, twice, 3 times, so there should be a 0 here and a 0 here, and there's our new decimal. We're looking at the number 0.004. So let's look at our options. Which one has both of these numbers written just like that? Well, that's too big. This one is also too big. That one's not right. B is the only one that has the right decimal and the right scientific notation. So for B, 4 times 10 to the negative 3, and our little decimal there, 0.004. So these are the steps you use to solve. Scientific notation is very useful for big numbers and small numbers, and we'll look at some more context with those kind of problems as we get more advanced and more comfortable working with these kind of numbers. But we can confirm that is the case. So if we can work on that and understand that, we will apply stuff now going forward and get more complicated as we go.